Hi everybody, good morning, good afternoon, good evening, depending on where you have joined us from. Welcome to Vikalti's DevOps Demo Come Career Guidance session. So today I'm going to walk you through what is DevOps and what are the career opportunities we have in DevOps, then why DevOps is so popular, and what would be the roles and responsibilities of any DevOps engineer in real time. And I will also walk you through all the tools that we have in DevOps, and I'll take a real-time project, kind of say Flipkart, and then I will explain how DevOps tools or DevOps culture helps Flipkart to boost development, QA, and then stabilize the operations, right? So I'll deep dive into each and every tool with a real-time use cases. That's about the agenda today, and you're all muted now. If you have any questions, you can post your questions in chat box. I'll be answering those questions. Okay. Right. Let's get started. DevOps. As part of DevOps, right? So we have these tools. First and foremost, we have something called Git. Git is called as a version control system. Then we have Maven. Maven is a build tool. Then we have Jenkins. Jenkins is called as CI/CD tool, which is very important concept in DevOps. You'll understand what is CI/CD, what is Maven, what is Git in a minute when we deep dive into those tools. Then we have something called Docker. Docker is a containerization tool. These days, applications are moving into containers, right? We call that as application containerization. All companies, all projects are trying to move to containers, right? We call that as application containerization. Why it is very popular, you'll understand that. Then we have something called Kubernetes. Kubernetes is an orchestration tool, or you call it as container management tool, which is open sourced by Google. This is actually Google's homegrown tool, and then I think around 2014 they open sourced it. We'll also discuss why Kubernetes is very important for any application. Then if you go to configuration management tool, we have something called Ansible, we have Puppet, we have Chef, and so on. Any one tool we have to learn in this particular category. We will also see how Ansible kind of configuration management tools help us to scale up the infrastructure or help us to automate infrastructure configurations. Then we have Terraform, which is a cloud provisioning tool, and any one cloud platform. I'm also going to explain how these cloud platforms help any project to auto scale, right, based on the demand. And if you're following the industry, DevOps world, there is a buzzword called Devsecops, right? Devsecops. It's a separate topic, but I'll also explain what is Devsecops and why Devsecops is very important, right, for any project. We call that as left shift approach, right? Why that is very important. These are the tools I'm going to explain, okay, on Flipkart kind of project. And as part of Gamut Gurus.com, which is exclusive learning platform for DevOps and then cloud. We don't deal with any other subjects except DevOps and then cloud. So we are kind of masters in DevOps and then cloud. DevOps course is very extensive. It will be around say 60 to 70 hours of live training. And if you take me for example, as I mentioned, I have 15 plus years of experience. I would have completed more than 300 plus batches now. That's about my teaching experience. And then I've been teaching for the last 7 years, and I would have trained more than maybe 10,000 plus students, corporate, online and stuff like that. That's about my experience. And my last company was Walmart. I was the first person to join in Walmart as a DevOps SME. There I got a lot of opportunities to learn the things at early stage. When DevOps coined newly, like say 8-9 years back, that time itself I got a chance to work for Walmart on DevOps. So that's how I started my a kind of career with DevOps. DevOps is not something new, right? So earlier, DevOps used to be called as build and release engineer. I started my career as build and release engineer. Later, they added some more responsibilities and coined a term called DevOps. I'll explain all those things, build and release, DevOps, and things like that. And here in Vikalti DevOps course, we have the nice LMS as well. Even if you miss some classes, you get class recordings, right? And everything is real time here. Personally, I don't believe much in theory. I would say 20% is theory and then 80% is pure practicals. It's all a real-time project oriented. Once you join the course, we give you a real-time project called Gamut Gurus, and you'll be practicing and then integrating all these tools by simulating real-time kind of scenarios. So it's not theory-based; it's purely practical. So once you complete the course, you get knowledge which is almost equal to 3-4 years real-time experience kind of training we have here, kind of training we provide. That's how the course curriculum is curated. Okay. So what I'll do now to make you better understand these tools, I'll take Flipkart as a project, and then we'll discuss all these tools on Flipkart. Okay, fine. Let me open the new slide. Right. Assume that this is a Flipkart. Okay, Flipkart team. Flipkart has, say, for example, 100 developers. What do these developers do? Developers write the code for application, right? Assume that Flipkart is developed in Java. In DevOps, dev doesn't mean that we have to do the development. We are not replacement for developers. We don't write the code for application. Here, dev means we automate development and then key teams processes. That is called build and release, right? You'll understand that. So it's a Flipkart. Flipkart has 100 developers, right? What do developers do? They write the code for application, right? So all these developers write the code in their local laptops or desktops. Then they place the code in a server called Git. So this is where Git comes in. That means it's a server. You install Git here. Once you install Git, we create something called repository. This is called as a repository. Think repository as a folder, right? And repository contains complete Flipkart application code. As a DevOps engineer, it is our responsibility to set up a Git repository and then manage the source code of the application, right? Say for example, a new developer joins in Flipkart. What does developer do? Developer, right, executes a command like this: git clone, and then URL of this particular repository. The moment this developer uses git clone command, Git clones the code in his or her local machine, and this developer adds some new files, modifies some files for fixing the bugs and features, and then they push the code back to Git. Again, other developer connects to Git. Again, they clone the code, they modify the code, and then submit the code back to Git. That's how different users, different teams collaborate with each other. That's how they exchange the code. So in Git, we store application code. We call that as source code. What do you call that? Source code. Source code can be anything. For example, this is called a source code. Whatever we directly write. Assuming Flipkart is developed in Java, if you go to Flipkart, Git repository, there would be a lot of .java files, right? Repository can have anything. For example, there may be some .java files, there may be some XML files, there may be some HTML files, CSS, there may be some images, JavaScript, some configuration files, and so on. So this code comes from developers, right? It's not only developers, QA, DevOps engineers, everybody writes something, right, for the application. Every day these developers write the code. Every day they submit the code to Git. Every day DevOps engineer clones the code, right? So for example, this is where DevOps activity starts. So every day DevOps engineers clone the code from Git and we get the source code here, right? Whatever you have here, Java, say HTML, CSS, or JavaScript and so on. This guy is DevOps engineer, DevOps. Once we clone the code in our machine, we compile this .java file, correct? Because you cannot directly execute .java file. You have to compile it before you execute. Assume that to create a login button, developer writes something like this, okay? Login.java. They write some code. If you execute this code, it has to create what? A login button, correct? If you go to any application, you have login button, search box, and things like that. So you execute this code has to give or say create a login button for us. But can we directly execute this .java? No. We all know machines understand only machine level language, correct? Or you call it as a binary, you call it as an artifact, you call it as executable. So you cannot directly execute .java. This is plain text. Only humans can understand this. Machines cannot understand, right? So that means, do we need to write the code in binaries, machine understandable language? No, we cannot write the code like this, correct? It's very difficult for us. So what is the problem here? You write the code in your own understandable language, machines don't understand, and whatever machines understand, we cannot write the code. So how do you bridge this gap? We compile it. Once we write the code, we have to compile it. The moment you compile, you know what happens? This compiler checks the syntax of this particular code, grammar rules and everything. If everything is fine, then it will generate machine understandable code. You call it as login.class. So our developers write .java and we compile it and we get .class file. And .class file is machine understandable language, right? Now you execute this on any operating system, you can get the output. You see now, at least in your college days, C++, maybe .NET or Java when you wrote, you would have compiled it, right? So why we compile the code? To generate machine understandable code. For example, if this is 100 lines of code, you get 100 lines of, say, machine understandable code, right? So what is the conclusion here? Without, compiling the code, you cannot execute, you cannot get the results. And how do you compile this code? Manually? No, right? If it is one .java file or say few .java files, you can compile manually. But if you go to Flipkart kind of application, you get hundreds of .java files or say thousands of .java files. If you go to Flipkart, you may be having 10,000 .java files. Is it possible for us to compile 10,000 .java files manually? No, right? So in software, when we have some manual tasks, what do? We try to automate it. That's why we think about some tool, correct? Here we have a tool called Maven. For that, Maven. Say you have 10,000 .java files. You just give this 10,000 .java files to Maven. Maven can compile all these 10,000 .java files and then generate .class files for us, equivalent class files, machine understandable code. So Maven is called as a build tool because it helps us to build the binaries. It helps us to convert this .java into .class, that is machine understandable code, right? Okay, as a DevOps engineer, it's our responsibility to automate this code compilation. So what we do here, once we clone the code, then we compile all these .java files and then we generate what? .class files. Assume that we have 10,000 .java files here. We get 10,000 class files, correct? This is machine understandable code, fine. To run the application, we need to have a lot of other resources as well. Like, we need to have some HTML files, you need to have some, CSS, JavaScript, some images and things like that. So whatever is required for the application to run, we separate everything into this particular folder. Say, for example, we have some HTML, CSS, some images and so on. Once we have everything in this particular folder, we compress it and then we create something called var file. For example, in this case, we call it as flipkart.var file. Web archive. Var means what? Web archive. think it as a zip file, right? It's kind of, zip file archive. And we call this process as what? Build process. Build. And using what? Using what tool we compile the code? Using Maven, right? So it's very simple. Developers write thousands of .java files. We clone the code, and then using Maven tool, we compile all these 10,000 .java files, and then we generate class files. We automate this code compilation process. We are actually building the binaries, building the machine understandable code. Can you launch application from this? No. Machines cannot directly execute the code, right? Somebody has to take the code, compile it, and then generate machine understandable code, that is class file. So we build applications. If you have this, you can execute application from this. You cannot launch application from this source code. It's kind of a raw material, right? Source. We build machine understandable code. Okay, that's what build means here. Okay, we have the var file. Once we have the var file, you know what we do? We go and then deploy that particular var file into something called Tomcat server. So once we have this var file, we go and then copy that particular var file into this server, Tomcat server. It can be anything, Tomcat, JBoss, WebSphere, WebLogic, can be anything. We call this as deployment, or we call it as release. Build and release or build and deployment. So what we do here, we build the var file and then we copy this particular var file into this Tomcat server. Okay, deployment means copying the var file into this server. That means it's a mission, right? You install Tomcat here and you start Tomcat server, and then Tomcat server executes this particular code, var file, and this has what? Mission understandable code. Okay, and this mission has some name. For example, name of this mission is Flipkart.com. Now you understand how Maven tool is helping, right, application to automate the compilation process and then deploy the code into the server, right? Flipkart.com, correct? So once we build and deploy the code, now real users can access the application. So how do we access Flipkart.com? For example, this guy is end user. We go to the browser and then we say Flipkart.com, www.flipkart.com. The moment users type Flipkart.com, no matter where the user is, where the server is, this particular browser connects to this mission, right? Okay. This mission name is what? Flipkart.com. And in this mission, who is there? Tomcat. Tomcat is running. Tomcat has machine executable code. Tomcat server executes the code and then it sends response back to the browser. And here you access your home page like login button, search box, and things like that. Again, you search something, again hit enter. What happens? Hit again, go to the server. Server, server executes the code. It may connect to some database. It gets the result and then it gives the results back to user. That's how this developer's code becomes as an application, correct? And in order to make this particular developer's code as an application, what do? Somebody has to take the code, build it, and then deploy it. And do we do all these things manually? No, we automate this process using our tools like using Git and then Maven. Clear now? Okay. So, Git is a tool where you can store your application code. It's not just storing the code. Git also maintains when there is a change, right? Who wrote this particular code or who modified a file, what time it is modified, why it is modified, right? It stores the code as well as the history of that particular change, right? So we call it as source code management tool or version control system. And you know what is Maven? We automate the compilation process and then we create the var file. Let's see what is Jenkins. In real time, whenever developer modifies the code, we don't directly build it and then deploy to the production, right? Why? We have to test it, correct? So what we do, before we deploy the code into production, we have to test it. So every day we build this particular var file and we first deploy this particular var file into some test environment. Name of this machine is flipkart-qa.com. Okay, here we deploy the code. So the moment we deploy the code into flipkart-qa.com, our QA teams test team, right, types flipkart-qa.com. Their browser connects to this. Real users are connecting to flipkart.com, that's a production. QA teams are connecting to this particular test environment, right? Environment means a mission where you have deployed your code. And then they access, daily bug fixes, features and things like that, and they test it. Again, if there are any errors, they report to the developers, developer commits the code, right? And then we take the code, we deploy it. So we work like this for a week, month, and once the code is stabilized, right? Once QA team says, okay, this code is working, then what do we do? One day we copy the same WAR file into this particular Tomcat server, and we call it as release, main release, or application release, or application is live, and things like that. Correct? Okay. So this is the production environment, and this is what test environment. There may be multiple test environments, right? One for manual testing, and then automation testing team. Maybe one more for system integration testing team, the other one for performance testing, and so on. Right? Okay. As a DevOps engineer, it's our responsibility to build the code and then deploy the code into all these test environments as well as production environment. Correct? And if you see here, we are closely interacting with development teams and then QA teams. Assume that we are compiling the code. There is some compilation error. What do? We report this compilation error to users, developers. Again, do we manually report? No. The moment there is some compilation error, right, our system, for example, Jenkins, identifies whose code it is, who broke the build, or who introduced that compilation error. It identifies and then it automatically sends email to the user, right? Again, say for example, developer is writing some code, and then that code is not part of the barcode because of some configuration issue in the manual. So these people work with us. Assume that testing team is accessing the application. This environment goes down. They come to us. Hello, DevOps engineer. This flipkart-qa.com is down. Can you bring this up? What do? We go to this particular server. We check if the Tomcat is running. We check if the right WAR file is deployed. We check if there is any disk space error or network error and so on. And we bring this particular server up so that QA teams can concentrate on their testing, or they can start their testing. So if you see here, we are closely working with dev team and then QA teams, right? Without we building the code and then deploying the code, there is no application for the QA. There is no application for real users as well. There is no application for dev team also to test. That's what dev means, DevOps, right? Here dev means dev and then QA teams, okay? So we automate development and then QA teams processes, right? We bridge the gap between dev and then QA teams, and we enable these two teams to work together. So the moment developers write the code, how the code goes to the QA, or how that becomes an application, and then how QA tests it, it goes to the DevOps engineer. DevOps engineer builds it and then deploys it. Then only QA teams can work on their daily testing. Correct? We're actually automating development and then QA teams processes. That's what the dev means, right? We work at a development phase and then testing phase as well, dev. Then comes ops. Ops means what? Once you deploy the code into your server, that is production, somebody has to monitor this production to make sure that this production is always up and running, no matter how many users hit your application, right? Say suddenly you get 1 million users, you should be able to run your application with the same speed, right? And who will work to stabilize this environment and stuff like that? Operations team, ops team. Who are those teams, right? There may be application support engineer, right? There will be a production support engineer. There will be a system administration team. There will be network engineers, right? Network operations center. All these teams work very hard, right, on production to make sure that it is always up and running and your application is getting served without any, right, say performance issue. That's what ops means, operations. Their job is only one, that is to make sure production is always up and running. Very challenging thing, right? Because this is where real users are connected, correct? So ops part is always challenging, and then we have to automate. We have a lot of automations, right, to make sure that application is running stable. I'm going to explain all those things. Operations. DevOps. So one person has to automate development and then creating process, build and deployment, as well as operations things also, right, which I'm going to explain. Right. So you have production environment, and then you have test environment. Let me explain what is this Jenkins and then where Jenkins come into picture. For example, this is where your Jenkins comes. So we take a mission, we install Jenkins. It's a web application, right? Browser-based tool. Once you install Jenkins here, we launch Jenkins in our browser. And then we create something called project, or you call it as a pipeline, or you call it as a job, or you call it as pipeline. It's a browser-based tool, right? So once you launch Jenkins in the browser, you will get, you create a project. That means it's a GUI, okay? It will give you a form. In that form, we have to integrate Git, Maven, and deployment steps. So here we give the Git URL. Wherever we have the code, we give that Git URL. And we give this Maven command, right? So the moment you give the Git URL, Jenkins will automatically go to this particular Git and then it will clone the code. Once it clones the code, what we have to do? We have to build it, right? So we give that Maven command, which will build the var file. Then we also give all deployment related commands, which will deploy the var file into Tomcat server. And we can also give some schedule basically here, right? What time you want to, how frequently you want to check Git for new code. We call it as a polling, right? You can also configure Jenkins in such a way that it connects to Git for every 5 minutes. And the moment there is some new code, the moment it detects the new code, it will take the code, it will build it, it will run this particular Maven, then it will run this deployment commands, and then it will deploy the code into given environment. Correct? Assume that developer is committing something at 2 a.m. right? Until and unless somebody builds it and then deploys it to this QA, this guy cannot test the application, correct? So does that mean that we have to manually, say, trigger the process? We have to be awake and then we have to take the code and then build and deploy? No. You just have, Jenkins tool, right? You configure this in such a way that it talks to Git for every 5 minutes. The moment there is a new code, it will take the code, build and then deploy it without any manual intervention. That's called as CI, continuous integration. Continuous integration means what? Continuous integration means a process which will detect the code coming into source code management tool, takes the code, builds the code, deploys into QA environment without any manual intervention. So it will seamlessly execute this build and deployment process in a continuous fashion. That's called as continuous integration. When there's a new code, how quickly you integrate this particular code into existing application, how you integrate it continuously, continuous integration. Get it? There's something called CD, right? Continuous deployment or delivery. What is CD? CI means deploying the code into your QA environment. So you take the code continuously, you build it and then deploy it here. Continuous integration. Once the code is deployed to QA, you can also automatically trigger some test cases. And if these test cases are 100% successful, for example, you can deploy the code into production. You call it as CD, continuous delivery or deployment. If you are deploying the code continuously into QA environment, we call it as continuous integration. If you are deploying the code continuously into the production without any manual intervention, we call it as what? Continuous delivery or deployment. CI, CD. People interchangeably, use these terms sometimes, right? So there's again subtle difference between continuous delivery and then deployment also. It depends on the project and then how you use this terminology. But in generic way, CI means test deployments, continuous deployments. CD means continuous deployments into prod. Okay. Now Jenkins, without manual intervention, it can continuously take the new code, build and then deploy it. And if there is any compilation error, Jenkins would automatically shoot an email to the user, whoever introduced that compilation error. Again, the moment the developer commits the code, our Jenkins is checking, right, for every 5 minutes. So it will take the code, it will build and deploy it. See here, level of automation that we are doing. These 3 tools, right, help dev and then QA teams to work together. In other words, using these 3 tools, we make dev and then QA teams work together, build and deployment. That's what the dev means, right? These 3 tools come under dev part. These tools come under ops part, right? Let's go to ops. If you go to Flipkart, do you think, there'll be only one server? No, right? If you have only one server, right, you cannot serve the application very, fast. If you go to Flipkart, for example, you'll be having, say hundreds of servers here. Assume that you have, 100 servers. 100 servers. All these 100 servers are under load balancer. That means the moment, user types flipkart.com, for example, 10,000 users or say 1,000 users, all 1,000 users request will come to flipkart.com. That's a load balancer. That means it's a mission. You install load balancing software here, and all requests come to connections, come to load balancer. Load balancer distributes different requests to different servers, different mission. Now you see how we are handling, thousands of user requests in parallel. It's 1,000 missions who is processing, 1,000 users request, or many users. So we'll be having load balancer, and then we'll be having multiple servers in real time, right? Okay. Assume that Flipkart receives 100 orders per minute, OPM, orders per minute, and Flipkart has 100 servers. For a simple math, take this way. To process 100 orders in a minute, you need to have 100 missions. Okay. Flipkart is planning for Big Billion Day. What is that? Big Billion Day, where there will be huge discounts and you'll be having more traffic. Kind of Thanksgiving Day, or Amazon Great India Sales, where there'll be huge discounts and then you get many users. There will be more traffic. So Flipkart is planning for Big Billion Day. In regular business hours, they get 100 orders per minute. During Big Billion Day, they expect, say for example, 500 orders per minute. Do they have servers to process 500 orders? No, correct? So what do? 10-15 days, right, before the release, Flipkart team adds 400 more servers to this load balancer. So that you can process 500 orders per minute. So that means they take a mission, they install operating system, they install, the Tomcat, JDK, they create a file with some permissions, they start Tomcat server, they may have to install, the database, a lot of things they do here in all this 400 missions, and then 400 missions are attached to the load balancer. So now totally you have 500 missions, and 500 missions can handle 500 orders per minute. Okay. Big Billion Day is on, right? They started receiving 100 orders per minute. You started receiving 500 orders per minute. Is there any guarantee that you don't receive 1,000 orders per minute? Possible, right? If you have to process 1,000 orders per minute, do you have the infrastructure? No. Do you have time to go and then add, say, 500 more missions? Do you have time to add 500 more missions? No. Correct. So what happens now? Since you are unable to add more and more, computing power or infrastructure, your application will become slow or it will be crashed. You give such a bad user experience. Correct. How do you minimize this risk is what the question now, right? How do you automatically add more and more servers? We call this a scaling up the infrastructure. How do you do it? That's where we bring Terraform, Cloud, and then Ansible together, right? For example, you have to create 500 missions and you have to configure, right? All these 500 missions, you have to install everything, Tomcat, JDK, and everything, correct? Can you do it manually? Do you have time to do all these installations manually? No. That's where we think about configuration management tool. For example, we have a tool called Ansible. What's that? Ansible. If you have Ansible, we write something called cookbook. Okay, it's a configuration file. Here we write something called playbook. Okay, if it is a chef, you write cookbook, you call it the cookbook. If it's Ansible, you call it as playbook. Here you can mention, I want JDK7, I want Tomcat, I want Tomcats are running. Whatever configurations are required for you, you mention all those things here at a very high level, right? And then whenever you need 500 servers, for example, just go and then apply this Ansible script. This Ansible can go to 500 missions and then install everything and then make the system ready for you, and then it will also join this 500 servers to existing load balancer. So and all this happens within few minutes. So what Ansible is doing, it is helping us to automate the infrastructure configurations. It is helping us to configure the missions, right? It can be application, it can be hardware, it can be anything. Configuration management tool. You have Puppet, you have Chef, you have different tools to do the same thing. Ansible is very popular. Okay. Now you are able to scale up the infrastructure with the help of Ansible. Now, from where you get this 500 missions? What if you need 1000 more missions? That means, do we need to buy before Big Billion Day? And next day, we don't need all these missions, right? We again fall back to the regular traffic and we need only 100 missions. So what do you do with this service now? If you purchase the infrastructure on your own, we have to manage this infrastructure. You have to again kind of have data center kind of environment. You have to buy racks, cables, AC, power cost, real estate cost, a lot of things. If you see down the line after a year, your maintenance cost would become double than purchase cost. So it's not a good idea to purchase the hardware. That's where we think about cloud, right? Cloud says it can be anything. It can be AWS, it can be Azure, GCP, it can be anything. Cloud says when you need some infrastructure, just look up at the cloud and then say, I need 500 missions. Cloud can give you 500 missions instantly. We call it as IaaS, right? Infrastructure as a service. When you need some infrastructure, don't buy, right? You go to cloud, you spin up 500 missions or 1000 missions, and then right you attach those missions to the load balancer, and then you are done. And they say pay for what you use, pay as you go. If you need these 500 missions for 24 hours, pay only for 24 hours. 48 hours only for 48 hours. Now we see, right, how we are scaling up the infrastructure with the help of cloud and then Ansible. So you create 500 missions from cloud, apply this Ansible, and then your mission is ready. Correct? That's where cloud platforms help us. As a DevOps engineer, see, cloud is different, DevOps is different. As a DevOps engineer, if we can have basic or intermediate level of cloud knowledge, that is kind of very much helpful for us. So in Vikalti course, you also get basic or intermediate level of AWS, whatever is required for DevOps engineer, right? If you want to concentrate on the cloud side, you should be taking 60-70 hours of AWS course or GCP or Azure, right? That's a separate course. Okay. And how do you create 500 missions at once? That's again a question, right? It's not that we go and then we create one mission, right? We configure network, maybe firewall rules, right? Maybe the regions and different things. How do you kind of configure this mission again, right? That's where we use something called Terraform, right? Terraform is called as cloud provisioning tool. What's that? Terraform. In Terraform, you write something called .tf script. Here you can mention, okay, I want 500 missions with these configurations, with this network configuration, in this particular region and things like that. And just execute the script. Terraform can provision 500 missions for you automatically, right? It can create 500 missions, infrastructure automation tool. You can create the infrastructure basically. You can provision the infrastructure from any cloud. It works, in AWS, cloud, Azure. It's a cross-platform tool. Not very important, but these days Terraform is also kind of all applications are going on cloud, right? So Terraform is kind of very popular these days again. It's again kind of a trending tool. You understand now how Terraform, cloud, and then Ansible helping us to scale up the infrastructure or scale down the infrastructure, correct? See the challenge that you are solving here, operations challenge. What is that operations team's job? No matter how many users are hitting the application, your application should be running, so it should be up and running in a stable manner. So who will take care of automatically scaling up and then scaling down the infrastructure? All these tools, cloud, Terraform, Ansible. If you don't solve this problem, your real users get impacted, right? So operations part. If you don't have this automation in place, we can assume the disaster, right? DevOps is very popular because all these tools help development teams to develop the application fast, QA teams to test the application fast, and then operations teams to run the application in a stable way. That's the reason DevOps is very popular these days. DevOps is a culture. People call it a culture. Means what? It is up to you whether you automate your application using these tools or not. It's up to you. If you have that culture, if you have this automation in place, now you can see, right, the benefits that we are getting. Whole world accepted that DevOps is next generation development methodology, right? Hardly say 20 to 25% of the companies are on DevOps. Remaining 75 to 80% of the companies are still trying to bring their applications on DevOps, trying to automate their builds, deployments, and then operations with these tools. That's the reason DevOps is very popular these days. That's the reason you have more salaries and then more job opportunities and things like that, right? As long as there's a software, DevOps is required. Git is required, Maven is required, Jenkins is required. All these things are required. So it's kind of evergreen domain for you, right? See, it's not only DevOps people, right? People who are working in this application support, right? Who works here? Production support, system administrators, and network engineers, all these desktop engineers, right? All these people come to me, they learn DevOps and they get into DevOps. And if you are working on any operations teams, it's time for you to upskill, because companies say, I don't want only application support, production support, or system administrator, right? I don't want only ops team. I want DevOps. I want a person who can automate the development plus operations part. That is the industry's expectation these days. Not only these operations teams, people who think that their career is not progressing well in some domain. For example, people working in QA, people working in say .NET, or people working in some even in some development domain, right? People who don't like coding, right? And people working in mainframes, kind of dying technologies. All these people come learn DevOps and they get into DevOps, right? So a lot of people are moving to DevOps. Now you know how Ansible and cloud Terraform helping us to automate that auto scaling, right? Scale up, scale down. Let me explain what is this Docker and then Kubernetes, right? You see this now. Before we deploy this particular var file, right, into this particular Tomcat, we need to have all the installations correct in this particular server. Before explaining Docker, let me explain virtualization first. See this? Earlier, we were having only physical machines, right? Physical servers. What is the problem if we have physical machine? This is a physical machine. Assume that you go and then install operating system on top of this, right? This is OS. On top of OS, you run your application. You have say 8 GB RAM, right? Say 16, say octa-core processor, and then say 500 GB hard disk. Okay, this is your hardware. You install operating system and then you run your application. Fine. No matter whether you use this 8 GB octa-core processor, 500 GB, no matter whether you use it or not, you have to dedicatedly allocate this hardware to this, right? For example, my laptop has say 1 TB. Am I using 1 TB today? No. I have say 16 GB. Am I using 16 GB? No. And when I need another mission, for example, what do? I have to go and then buy the hardware again, right? For this mission. Again, you install OS and then run your application. So if it's a physical mission, you cannot utilize the computing port to its max capacity. You cannot, utilize. So you are wasting a lot of hardware basically. For example, you have this hardware, you are running some application. Assume that you want to run this application in kind of microservice architecture. You want to run different services on different missions. So what you have to do? You have to again buy the hardware. Again, you run database on one mission, right? Say for example, this is OS. You run payment gateway here, and then different missions, right? Again, you have to buy the hardware here, and then here. You are not using the hardware that we have, and then when you need a new mission, you are again buying the hardware. And are you using this particular hardware to its max capacity? No. So you're wasting a lot of hardware here. That is the problem with physical mission. So people came up with something called what? Virtualization, right? Means what? So you have the operating system. For example, this is your OS, right? On top of OS, you go and then install virtualization. This is your operating system. Here you install virtualization. Using this virtualization technology, like VMware has virtualization solution, right? Oracle has. Using this virtualization software, you can create multiple missions on top of the same piece of hardware. You don't need to buy, right? On top of the same hardware, RAM, CPU, and then hard disk drive, you can create multiple missions. So this virtualization helps you to virtualize this particular hardware. So here you get the hardware. You don't need to buy. Same hardware is distributed to all these missions, and then you install operating system on top of this OS, and then you can run your application here. Application 1, application 2, application 3, and so on. Correct? Are you wasting the hardware here? No. So this virtualization technology is helping you to create multiple missions, right? Okay. Virtualization is great. Even today, virtualization is popular. But world is moving from virtualization to something called containerization. What is that? See this. This is your, say the hardware, right? Then you have operating system. On top of operating system, here you install something called Docker. This is your Docker. This is your OS hardware. Using Docker also, we can create multiple missions like this. When you can create multiple missions using virtualization, why you need Docker again? What is the difference between virtualization and then Dockerization or containerization? What is the difference? Why infrastructure or applications are moving to Docker, right? Let me give you the difference. If you have ever created a VM, you know this. To create a VM, you need to install operating system. That means each and every VMs, right? VM1, VM2, VMn. Each and every VM has its own operating system, 2 GB operating system. Since you have to install the operating system, it takes more time to create a VM. Almost like 5 to 7 minutes you have to spend to create a VM. It takes more time to create a VM. And operating system is a core, right? So that means what? Operating system also consumes some hardware, some computing like RAM, CPU, hard disk. So by having the hardware here, by having the operating system, you're wasting a lot of hardware, and then it is taking more time for you to create a mission, right? So it takes more time to create new mission. It takes more time to start the mission. It takes more time to stop the mission. Since there is an operating system, the moment you switch on the power button, you have to wait for operating system to come up, correct? So it takes more time to create, start, and then stop it. Yeah, again, you have to wait for the shutdown, right? This is not the case with Docker. If you are creating a mission with Docker, you call it as container. Container 1, container 2, container n. Okay. What is what is so special about Docker? See this. To create a container, you don't need to install any operating system. You don't need to install any operating system. But without operating system here, right? How do you run your applications? Question, right? That's a beauty of Docker. Docker virtualizes the hardware, and think this way: Docker also virtualizes operating system. That means without you installing operating system, it creates operating system kind of environment virtually. This particular machine don't have 2 GB operating system code. No, it gives operating system kind of environment. That means without you installing the operating system, it gives OS environment. Means it will give a separate IP to this machine, right? It will maintain separate process tree. That means whatever you are running here, you cannot see all those things here, right? It will give a separate networking capabilities. You can decide who can connect to this machine or no, to what missions this machine can connect. So without you installing the operating system, you get all these features. So you can think in this way: Docker virtualizes the hardware as well as operating system also. It's not that all these applications are running on kind of a dedicated operating system. It gives a feel to the user that yes, your application is running on dedicated OS, but actually speaking, all these applications run under same operating system, right? It's a virtual operating system kind of environment for you. It's a 2 hours discussion. If it's a real class, I spent 2 hours just to explain how Docker creates that virtual operating system kind of environment, right? It uses something called C group namespace kernel features. Using those features, it will give that operating system kind of feeling to you. So end of the day, you feel that yes, your application is running on a dedicated OS. So each and every container don't have separate operating system. Since there is no operating system, since you don't need to install operating system, what happens? It takes very less time for you to create a mission, correct? Very less time. In fact, you can create a container within less than 1 second. See this. Within 1 second, you can create a mission. To create a VM, it takes close to 5 to 10 minutes. Because you don't need to install operating system. So your mission creation is very quick. Think those big billion days kind of days where you have to go in and add more and more missions quickly. If it's a container, you can create 500 containers within few seconds or minutes, right? See the advantage of containers. Okay, you can start the containers very quickly. You don't need to wait for the operating system to come up. You can shut down the containers very quickly. You can start, you can create, you can stop containers very quickly. It takes very less time. Within less than 1 second, you can create a mission, right? And moreover, container is lightweight and VM is heavy. Heavy in the sense, as I mentioned, 2 GB operating system, right? Operating system also consumes some computing, right? Say, for example, you buy 64 GB mobile. Do you get 64 GB? No, you get hardly 58, 60 GB. Where is remaining? That is occupied by your iOS or Android operating system. So by having operating system, you are wasting a lot of hardware. Since there is no operating system here, right? You save a lot of hardware. If you can create say 5 VMs on this particular hardware, you can create 50 containers with the same hardware, 50 containers. So you can create more and more missions on top of less hardware. Today, Google search, Gmail, Google file system, lot of Google's large scale enterprise applications are running on containers. Containers started, the world started using containers say 6-7 years or 8 years back, whereas Google started using containers 13 to 15 years back, right? Google runs millions, billions of missions. Google, runs millions of missions to, search. I mean, to deliver the search, or Gmail. They cannot afford to have physical missions, right? If there is, say VMs, it is very costly affair for them, right? That's where they have a lightweight solution, that is container, right? It's cheap, it's fast, right? And then it takes very less time to create, start, stop, and all this stuff. That's why containers are very popular these days. Docker has another beautiful, feature called image. You know what you can do? In traditional deployment model, you know what we do? Once the war file is created, before we deploy the war file, we have to have a mission, right? And you have to install JDK, all the dependencies, right? To run this particular code, you need to have the JDK, you need to have the Tomcat, you need to have a lot of softwares. So you have to install all these things, correct? And if you have again multiple environments, it becomes challenge for you to make sure that all your environments and then production has the same version of the tool and then the same tools. If there is any version mismatch, things will work here, it will not work here, right? There's a lot of confusion there, right? So how do you maintain that consistency across all your environments, right? How do you make sure that all environments has the same version of the tool? Very difficult, correct? If you have Docker image, you know what you can do? You don't need to manually install all these things. You don't need to take care of the dependencies, right? You can create something called image here. What is that? Image. So here you have the code, right? Basically, this is your code, and you can bundle JDK. You can have Tomcat. You can have everything here. Anything. So you can have, say for example, Python and things like that. So this is what is image. Think image as a zip file. Image is nothing but a zip file. So once you compile the code, once you get machine understandable code, whatever is required for you to run that particular code, you bundle all those things in something called image. It's a zip file, and from this image you can create environment. So you want 100 missions, you can get 100 containers, and you know what happens, right? Whatever you have bundled in the image, same thing comes in this particular container. That means you get the code plus all its dependencies. You understand this? See how easy it is, and you are able to do this within less than 1 second. Within less than a second, you are able to create a mission which has the code dependencies. See how fast it is if you want to scale up during big billion day or anything, correct? And content is lightweight. You know the advantages of all those containers, right? We call this as application containerization. How do you containerize your application? How do you run your application in containers? If you want to run your applications in containers, what do you have to do? Once you build the code, right, we have to create the image. From image, we create the containers. Containers are created from images. And when you create the container, whatever you have in the image, everything comes here. See this, correct? That is the reason Docker is very popular these days compared to virtualization. In fact, infrastructure is moving from virtualization to containerization. As a DevOps engineer, it's our responsibility to create the image and then create all these environments. And we should know it's a command line tool again. All these tools are command line tools. We don't need to write much code, right? Or we don't write the code. There is a misconception, right? Dev means people think that, oh, I have to do the development. No. As a DevOps engineer, sometimes we write scripts, right? Like Python, Perl, Shell. If you know those scripting languages, it is kind of added advantage. It's not that we'll be extensively writing the scripts, right? So again, it depends on the application, and things like that. But what I say, there won't be much coding here, right? What all we have to do, we write, simple scripts basically, right? As part of Vikalti's DevOps course, right? Apart from the 60-70 hours, you also get shell scripting, which is 30 hours, which is worth, say almost 8,000 rupees. This is free. These are the recorded classes. Okay, so if you take DevOps, right, 60-70 hours plus 30 hours of shell scripting, right? So scripting Again, if it is kind of added advantage, if you learn scripting also, it will kind of help you to get a good job in a good company with better package, right? We cannot learn everything overnight. Usually people first learn DevOps. Once they get into DevOps, then they start focusing on learning one scripting, right? Scripting is not again kind of very difficult like Java, C, C++, right? It's a lightweight program. Okay. So you know what is Docker. Kubernetes, in application deployments, usually these are the challenges we face. For example, right, you have the code, new code. For example, these servers are running some n code. You get n plus 1 code, new code. You have to deploy this particular code into the environment, correct? So the challenge comes, how do you deploy this particular new code in all these missions without bringing environment down, correct? So your real users are accessing the application, right? Without impacting real users, you have to push the new code. If you see, some websites, you would have seen this, right? We are deploying something, some new code, right? The environment is down, right? Website is down. Please come after, say, 2 hours, 3 hours. Have you ever seen such things with Facebook.com, Google.com, Gmail? No. They push the code without bringing environment down. We call it as GDR, zero downtime release, right? How do you do it? If you have to automate this, it's very difficult for us, right? If it is a Kubernetes can get this job done very easily for us. So assume that you have 100 containers, correct? 100 containers. And you run all these 100 containers inside what? Kubernetes, okay? You are running 100 containers inside the Kubernetes cluster, or you call it, think it, as you're running all these containers under Kubernetes. Okay, so these containers are running inside Kubernetes, K8s in short. Kubernetes, KS, between you have 8 characters. Okay, so Kubernetes is helping you to deploy the new code without bringing the environment down, zero downtime release. Second thing, assume that you always want to maintain 100 servers. How many servers? 100 servers. You want to have 100 servers at any point of time. What if 10 servers go down? You have to bring 10 servers automatically, right? So for this, you have to set up some monitoring tool to understand that, okay, 10 missions are down. Again, you have to add 10 missions up, correct? If you have 90, for example, your application will become slow. So how do you, automatically bring 10 servers up when something, right, goes bad? We call this as self-healing. What's it? Self-healing. How do you make your environment self-healable? When there is an issue in the environment, how do you make your environment get repaired on its own? If it's a Kubernetes, you know what you can do? You can tell Kubernetes, hello Kubernetes, I want to have 100 containers at any point of time. If 10 goes down, Kubernetes understands that 10 went down, and then it will automatically bring 10 up for us. Self-healing. It is helping us to make our environment self-healable, right? Third thing, auto scale. Again, when you have more load, you have to go and attach more and more missions. When you have less load, again you have to remove the missions, right? Otherwise it's a hardware cost. So we will do that auto scale. That's about, if you have the Kubernetes can get this job done very easily for us. Application rollback. You push the new code is not working properly, and you have to bring the old code back, right? Roll back. How do you roll it back? If you want to automate all these things on your own by writing shell, Perl, Python scripts, you have to write thousands of, you have to write, hundreds of scripts basically. Very difficult. So Kubernetes is a tool, right? It has that intelligence automatically. Kubernetes was Google's homegrown tool. As I said, Kubernetes runs millions of containers. Who manage all these millions of containers? It's not practically possible for anybody to manage, right? Millions of missions. That's where they developed something called Kubernetes, right? In Google, It was Borg, B-O-R-G, Borg. When they open source, they named it as Kubernetes. Kubernetes has experience of running thousands of machines, experience of running large scale applications like search, Gmail, right? So Kubernetes is very popular these days. If you have Kubernetes, you can manage your containers very easily with all these features. That's why you call it as orchestration tool, or you call it as container management tool. Using this Kubernetes, you can easily manage containers. Understand? Now you see, right, how these tools are helping Flipkart. If it's it can be Flipkart, it can be any application. So DevOps is very popular. That's why. Okay. Devsecops is again kind of 2 hours topic. It is. Think this way. 2 hours topic I'm explaining in 2 minutes. Okay. Take it that way. I'll schedule a separate webinar maybe in the future, and I will invite you for Devsecops also. Okay. There I'll talk about only Devsecops, why it is very important. What is sec means, right? Where it is helpful, in what kind of projects security is helpful, where you integrate different security tools in different phases, right? So all those things I'll talk about. But let me quickly explain this in 2 minutes, because focus here is DevOps, right? If you have not registered, with us, say for example, you can go and get registered so that you get updates about all this webinars and things like that. We conduct a lot of webinars on cloud, and DevOps and things like that, free webinars. You can go and then like our pages in LinkedIn, YouTube, Facebook, so that you get updates about all this. Right. So what is security? If you see, DevOps is actually bringing development team, correct? DevOps process, culture, right? Tools, bringing development teams, QA teams, and then operations teams work together, correct? Dev writes the code, DevOps engineer builds it and then deploys it, then QA guy comes and then tests it. Once it is tested, then we move to the production, and then we also automate the ops part, right? Operations. So we are not replacement for the developers, we are not replacement for the QA, we are not replacement for operations teams. It is just that using our automations, right, we bring all these teams together on the same page, so that the code can be developed, tested, right, and then move to the production seamlessly. Can move to the production very fast. So we're actually connecting all these teams, right, with our automations. But if you see security, you're not talking about the security here, right? Security team usually today, say works in a different silo again, right? And security, usually happens in production directly in live, because they want to, check the security related vulnerabilities with the live users, or you do it usually, at the time of QA basically. Assume that you are doing security here or in QA. Let's take the worst case, okay? If you are doing the security in the production, there is some issue. You report that issue to the developer. Developer says, I need 3 days time, or he says, I need 1 month time to fix it. I have to, kind of restructure the complete application. I have to change the architecture of the complete application. So that's a kind of a surprise for you, right? Or in QA, whatever. So basically, since you are not worried about the security, since you are identifying those security issues at later stages, like in QA and then production, it's becoming difficult for you, right, to kind of fix, or by the time these people report, the damage already happened, or you report and then these people cannot quickly fix it. Kind of confusions. So what SEC says, security, instead of doing it at the end, why can't you start automating the security things, or start running your security checks at the time of development itself? Correct. So the moment developer write the code, right, at the time of development itself, it will tell you, okay, you are embedding username and password in the code itself. Don't do it. You are copying the SSH key. It's a security kind of vulnerability. Don't do it. you are writing the code, which will allow users, to connect to your application, right, as a root user, right? Say attackers can very easily take over the mission, and then they can do anything there, right? So at the time of development itself, you have some tools like PMD, check style, right? There are some tools. Basically, using those tools, you can identify all these things here itself. Okay, then that means some security part is taken care. So you have got the new code here. Again, you take the code. Once we do the build, again you run some security, scans here. Assume that, say for example, your developers copies the code somewhere. What is the guarantee that that code is not IP of some company? Correct. It can be, intellectual property of somebody else. And if you use their code in your application, they may sue the company, right? You would have heard about this, right? This company copied the logic of other company, and then they are paying kind of fine or things like that. So what is the guarantee? How do you identify those licensing issues? Once the build is done, you can scan the code. There is something called block duck. One second. There's a tool called block duck. Okay, just give your code to this block duck tool. It scans your code and then it will tell you whether it's an open source code or what it is, what kind of license that code has, and things like that. So you are running security here also. You run some tools here like nmap, you have some WASP 10 rules, right? You have some find bug kind of tools. If you run those things here, right, you get a lot of security issues when solved or you identify. Then you run in the production also. So you are able to integrate the security things at the time of development, at the time of QA, at the time of say build, and at the time of production also, right? So Devsecops says you have to inject security tools automations at the time of development itself, at the time of build itself, at the time of your QA testing itself, so that a lot of security things can be identified very quickly at early stages. It's like identify fast. More levels of testing you do, more issues you identify, and then more quality code you can generate. Correct? So DevSecOps insists us to have the security tools at the time of dev, QA, and then kind of production, right? Instead of doing at the end, say for example, this is left, right, dev, QA, right, your production. Instead of doing in the production directly, why can't you start here itself at earlier stages itself? We call it as shift left, right? Don't do it at the right in the production. If possible, do it here, QA. If possible, do it during build. If possible, do it during development itself, right? Shift left approach. DevSecOps is very important, especially if your application is banking, kind of finance. As part of faculty's course, we also teach you DevSecOps, right? Primarily, I handle most of the DevOps batches. There are other trainers who are actually more experienced than me also, right? All our trainers are industry experts, like people working in Google, Microsoft, kind of top technology centric companies, and these guys are like 12 plus years of experience, and kind of masters in the subject and masters in teaching also, right? And whatever faculty teaches, we always teach with the trending topics. It's not that you come and then like a lot of people still teach DevOps for 35 hours. Can you learn DevOps all these tools in 33 hours? If you split, hardly get 3 hours. You cannot learn Kubernetes in 3 hours, Docker in 3 hours, Jenkins in 3 hours. No, right? So it's very extensive, and it's real-time project-based training with trending topics like DevSecOps, right? As I said, faculty is laser focused. It's exclusively only for DevOps and then cloud. We don't have other courses. Okay. DevSecOps, right? Inject security at the time of development, build, QA, and production. That's about DevSecOps. Okay. Before I take your questions, I'll just give you, the batch details quickly. So we have daily, and then weekend batches, like daily means Monday to Friday. Weekend is Saturday and Sunday. We have morning batches and then evening batches. Morning and then evening batches. Okay. Most of the evening batches I take care, and then morning batches, other trainers take care usually. If you have any questions about the course or enrollment and things like that, you can reach out to the support team, or if you go to weekly.com, you get a chat window, you can leave your number there, or you can directly enroll from the Wickilty itself, paying online. And we also have AWS separate course, Azure, right, GCP, Python, plus DevOps. All are DevOps related, DevOps and cloud related. Okay, that's all I have from my side. If you have any questions, you can type your questions in the chat box. I have a lot of previous questions in chat box. Okay, and I think I have questions. I will explain these questions to you later. I'll send you an email, a personal email with answers by end of the day today mostly. If you have any questions now, you can put it in the chat box. Great. Thank you very much for joining me today evening. I'm in Bangalore, India. Have a nice day, good night, depending on where you have joined us from.